We're going to be doing Teach Me How to Factor 5 today. We're going to do a problem or do these problems together. Let's go to work. Number 1, 9n squared minus 25. How many people have it? What do you got, Althea? 3n minus 5 times 3n plus 5. This is called the difference of squares. Difference of squares. You should see that quickly. Let's try the next one. Number 3. You should be writing the problem and your answer, even those you who can do it really fast. What you got, Alex?
5k plus 2 and 5k minus. Minus 2.
5k plus 2 and 5k minus 2. Excellent. Again, it's a difference of squares. You should be able to identify when you see two perfect squares separated by a minus sign. Okay? Difference of squares. Number 5. Mr. Crank, you got it?
Yeah.
What you got? Very good. 4n minus 5 times 4n plus 5. How do we feel about difference of squares now? Easy peasy lemon squeezy. Should be easy. We had 2 types of special ones. What were they? Difference of squares, these ones we did, and perfect square trinomials. What was the difference? The perfect square trinomial has a middle term or junk or a linear term, right? Difference of squares does not. So the difference of squares is a little bit easier to identify than the perfect square trinomials. But in both cases, what's at the front and the back? Perfect squares. Perfect squares. Let's try number 7. Cam? No idea? None? Riley? What do you see in this one? She's not here. Althea? McKenna? You know, nothing jumps off the page and smacks you in the nose. Cam? Perfect squares. What are they? 16 and 25. There's two perfect squares. Okay, that ought to jump off the page at you. Those numbers are special. Okay, so we're thinking this might be a perfect square trinomial. Well, what's the square root of 25? And the square root of 16? 4 times 5 is 20. 20 doubled is 40. So guess what? This is a perfect square trinomial. Since it's a perfect square trinomial, Riley, how do I know that it's a perfect square trinomial? Because of what I just did. I take the square roots and I multiply them together and I double it. If that gets me my middle term, it's a perfect square trinomial. Okay? If that happens, that's what I have. So I have one now. I'm sure of it. Since I know I have one, it's as easy to factor as the difference of squares. Matter of fact, it's almost identical. So the square root of 16, we already said, is 4x, and the square root of 25 is 5. Now, is it plus or is it minus? Why? The second sign goes right there. And then put a parenthesis around it and squared. I mean, and that's the same thing as 4x plus 5 times 4x plus 5. Those mean the same thing. But in all reality, we like this one a little bit better. Very good with a perfect square trinomial. All right. Let's try number 9. Emily? So you think it's a perfect square trinomial? So, you seem so unsure. How do you know? It has a perfect square at the end, perfect square at the front. That's good. What's the square root of 4? What's the square root of 25? 2 times 5 is 10 doubled is, yes, it's a perfect square trinomial. So it becomes rather easy. 2x plus 5 quantity squared. Now, what if I gave you this one? I want to be devil's advocate here. 4x squared plus 5x plus 25. Looks awful familiar, or it looks awful similar, doesn't it? Is it a perfect square trinomial? No, because as we multiply these square roots, 2 times 5 is 10. 10 doubled is not 5. At that point, see, that can happen. That can happen. If that's the case, then we realize, hey, this is not a perfect square trinomial, so I have to go through our normal factoring techniques, which would be, is there a GCF? Is there a leading coefficient? box method, splitting signs, whatever I need. Do you understand? So that's why I always like to check and see, hey, is it perfect square or not? And if it is, it becomes easy to do. If it's not, okay, I got to do my normal stuff. Is that cool? All right, let's try one more. Leo, what you thinking? No, I want you to tell me what you're thinking. When you looked at it first, what were you thinking? First thought was, is it a perfect square trinomial? And when you thought that, what'd you do? Took the square root of 9, which is 3, and took the square root of 16, which is 4. What'd you do with those? 3 times 4 is 12, and then doubled it to see if it was 24, which it is. Okay, now you know it is a perfect square trinomial. Then what you do? Three x minus 4 quantity squared. Okay, say that when you want to put like the whole parenthesis to a power, say quantity squared. Quantity means, hey, put a parenthesis around it. Okay, how many people got that one right? Good. So the two special cases, difference of square and perfect square trinomial, we're good? Golden. All right. Number 13. Who's ready? All right, go ahead, Zyler. Not perfect square. It's not special. It's just regular. So since it's just regular, what's the first thing I ask myself? Is there a GCF? Is there? Yes. What is it? I can pull out a 4. So in my head, I'm now thinking 4k squared divided by 4 is k squared. And then 4k divided by 4 is k. And then negative 224 divided by 4 is, say again, negative 56. Okay, am I done? No, I just took care of my GCF. Now I still got to focus on what's inside the parenthesis. Okay, so I go to my next question. Inside the parenthesis, is there a leading coefficient? No. So split in signs. So the 4 stays, and then I split, put a k in each. Then I look at my signs. I start with my last sign, and that tells me they're going to be opposite, a plus and a minus. Now what? List the factors. List the factors, the constant. In this case, the constant is 56. What are the factors of 56? 1 and 56, 2 and 28, 4 and 14, 7 and 8. Which of those come together to get me a 1 with opposite signs? 7 and 8, the larger number gets a sign from the middle, so the 8 has to be positive and the 7 negative. Look good? How many people got it? That's not enough. It's not even close to enough. For those of you who didn't get it, do you understand? Ready to try another one? By a show of hands, how many people think this one looks funny? It does. It's missing parts. But it doesn't change the process. Is there a GCF? Yes. What is the GCF? N. So I can pull out an N. So then I'm thinking to myself, N squared divided by N is N. And then negative 3N divided by N is negative 3. Done. How many people had that one? Okay. Let's try the next one. Mr. Sable, what you got? What's the first question you ask yourself? Is there a GCF? Is there? No X in the last one. So no. 25 is a 1. And 25 doesn't go into negative 10. Is there any number or variable that goes into all three of these? 1 doesn't count. I mean, 1 does, but 1 doesn't count because 1 goes into everything. 5 doesn't go into 1. So is there a GCF? No, no GCF. Is there a leading coefficient? 1, again, doesn't count. 1 is the loneliest number that you've ever seen. 1 is the loneliest number.
Oh, the loneliest?
Loneliest.
I thought it was lowest.
Yeah.
Is there a leading coefficient? No. So, splitting signs. X and X. Signs tell me they're going to be same, and they're both going to be negative. Now I need the factors of 25. 1 and 25, 5 and 5. Which of those come together to get me a 10? Those look identical. Couldn't I write this as x plus, oops, not plus, x minus 5 quantity squared? Yeah? Huh. Anybody see anything interesting? It's a perfect square trinomial. Maybe at the very beginning I had noticed that this was a perfect square and 1 is a perfect square. What's the square root of 25? What's the square root of 1? 1 times 5 is 5 doubled is. Now, so here's the reality when it comes to the perfect square trinomials. And you know what? The same thing would be true for the difference of squares too. I can still use my normal everyday process of is there a GCF, leading coefficient, splitting signs, or box method, and it's still going to work. It's still going to work. Do you understand? If I don't recognize the fact that that's a perfect square trinomial, I can still go through the same process and get the same answer. Isn't that interesting? However, if I can identify it as a perfect square, I can do it a lot faster. Do you understand that? No, maybe. All right. 19. Boy, Peeper, what's the first question?
Is it a perfect trinomial?
Is it perfect?
No.
No. Okay, not perfect. What's your next question? Mendoza? Is there a GCF? Is there? What is it? 5. 5 can go into all of that. 5 goes into 5m squared times. 5 goes into 45m 9 times. And 5 goes into 120 times. So far, so good. Now I'm focused on just inside the parenthesis, just this portion here. And I basically ask myself the same question. Is there a GCF? No. Is there a leading coefficient? No. So split and signs. Split it into 2 sets of parentheses. Put a variable in each. Signs are the same and positive. Plus and a plus. Now what, Cam?
You do thingies of 20.
The thingies of 20. Absolutely. All the thingies of 20. 1 and 20, 2 and 10, 4 and 5. Which of those come together to get me a 90? Which one of those thingies come together to get me a 90? 4 and 5 are the thingies. Okay? 4 and 5. AKA factors. Okay? We want to get technical. They're called factors, but more lovingly known as thingies. Okay? Number 21. Number 21. Come on, you can do it. All right, Althea, what's the first question?
Does it have any perfect squares?
Is it perfect squares? No, no perfect squares, so not special. Is there a GCF? Yes. What can I pull out? 6 x squared minus 2x minus 15. Everybody okay with that? Now, just focusing on the inside. Is there a leading coefficient? No. So, splitting signs. Put an x in each. Signs are opposites. So I can go ahead and put them in, a plus and a minus. Now what? List the thingies. All the thingies of 15. 1 and 15. 3 and 5. Which of those thingies come together to get me? 3 and 5. Larger number gets a sign from the middle, so the 5 has to be negative. We getting there? Can I get a whoop whoop? 23. How many people think this one looks funny? All the ones that have looked funny, what have we found? A GCF. Is there a GCF? What is it? 5 and n. So what's left? N minus 2. How do I check my work? Foil or distribute? Okay. Do the thingy. Yeah. I'm giving you too hard of a time, Cam. You can handle it. All right, 25. First question. What's the first question, Mr. Crank? Is there a GCF? Is there? No. He says no. How many people disagree with him? Good, a lot of you. What is the GCF, Mr. Mendoza? 4. 4 goes into 12 3 times, so that's 3n squared. 4 goes into 100 25 times, and 4 goes into 72 18 times. Okay? Now, if I just look on the inside, is there a leading coefficient? Absolutely. Since there's a leading coefficient, what do I have to do? I got to do the box method. Okay? I'm going to do the box method. 3n squared and a negative 18. Now what? Multiply those two. Some of you, when I get to this box method, you start daydreaming a little bit. Stay with me, please. The easiest thing to do is put the first term and the last term in. And that's when people start falling asleep. Don't fall asleep. We have to multiply the numbers. 3 times 18 is 56. Now, I need to list the factors of 56, just like I have with the constant over and over again. So, list the factors of 56. I got 1 and 56. Thank you. Apologize. 54. 54, not 56. Thank you. 54. All right, so 1 and 54. 2 and 27. 3 and 18, 4, no, 5, no, 6, and 9. Which of those come together to get me a 25 with opposite signs? 2 and 27. The larger number gets the sign from the middle. So the 27 has to be negative. So then I put those two numbers with a variable in the other two boxes. Negative 27n and 2n. Is everybody okay with how I filled out my box? Yes? All right, now I find my factors or my GCF of here. 3 and an n. There's an n in both of those. Here, 2. Then up and down, just an n. Up and down, a negative 9. Why is it negative? Because that sign right there is negative. Whatever the sign is in the box goes with it. Like this one is positive, so that's positive. That's just the way it goes. Makes it easier with the signs. So now this 4 just moves down, and I'm left with 3n plus 2 and n minus 9. That's the box method. That's the box method. Let's try another one. 27. Give you a little hint. There's no GCF. There's no GCF. Good luck. All right. Was there a GCF? No. Since there's no GCF, is there a leading coefficient? Yes. Since there's a leading coefficient, I go to the box method. You'll look on the board. You see I go ahead and already made my box. And I put in my first term and my last term. While you were working, I was working. 7 times 32 is 224, correct? Then I had to start listing the factors of 224. I'm going to keep listing those factors of 224 until I find two numbers with opposite signs that add together to get me 52. So I found 1 and 224, 2 and 112, 4 and 56. 56 minus 4 is 52, so that's the one I'm looking for. The larger number got the sign from the middle, so the 56 had to be positive. making the 4 negative. Now what do I do with those numbers? I put them in the other boxes. Negative 4x and 56x. Everybody okay with where I got my numbers? Wonderful. So now I GCF x 8 7x negative 4. So I've got 7x minus 4 times x plus 8. Questions? Yes, sir.
I thought since the signs are opposite, the middle sign goes first.
Doesn't matter. So you want to go x plus 8 times 7x minus 4? Okay. Doesn't matter. Once you get to this point, once you get to there, you can put those two sets of parentheses any way you want, because remember, it's multiplication and it's commutative. 3 times 4 is the same as 4 times 3. Did I answer your question or no?
I also got 7 instead of negative.
Say again.
I got 7 instead of 4.
Right here. Well, when you go, oops, undo. When you go and multiply, at the end, 4 times 8 is 32. But if you go 7 times 8, that won't be 32. Okay? All right. I want to do the next one. Oh, go ahead. Number 29. Go. Anybody think it looks funny? What's it been almost every time it looks funny? Yeah, GCF. What's our GCF? 24 R. R minus 10. Whew. $31. Raise your hand when you got it. Cam? 3b minus 8. 3b plus 8. What is that called? Difference of squares. DOS. All the students got to get it. You better recognize when I spit it. All right. Questions, comments, concerns. Coming up on your Google Classroom. Popping up in about 2 minutes will be that worksheet that I just did. Okay. It is called Teach Me How to Factor 5. I want you to do the evens. I want you to do the evens. You can do it on that same paper. That's why I told you only use the half of it, yes? Questions, comments, concerns? It'll pop up there in a minute. All right, luck, y'all. Have a good day.